Hello, and welcome to problem set 35. Today, we are going to cover a bunch of different integrals. Just like you had rules for derivatives, you're going to have a bunch of rules for how to take the integral of things. And the three integrals that we're going to talk about today is the integral of a constant, k, the integral of k times a function. So if I multiply a function times a constant, and then finally, the integral of x to the n. So I'll give you the quick and easy rules right away. How do I get a constant after I take the derivative? Well, I need the function there. I'll give you an example in a moment, but the idea is that if I want to get a constant out, the integral of that has to be a linear function, right? Because the slope of the line is always the same. So, integral of a constant, simply kx plus c. That should appear in your notes. Now, what happens if I want the integral of a function multiplied by a constant? As long as that constant number doesn't depend on the variable of integration, well, that's simply k times that function. So, we pull the constant out, and we integrate the function as normal. Easy as that, just like we did with limits. Remember, limits, and derivatives, and integrals are all tied together. So those things that work for limits usually work for integrals and derivatives. Now, what about this one? This one's a little tricky. Let's think about this for a second. So if I take the derivative of x squared, I get 2x. So what happens if I integrate x? We'll just divide by 2 here. If I integrate x, then I get x squared over 2. Okay? What happens? Well, when I took the derivative, I brought the number as a power down in front, and then I subtracted 1 from the power. So, to do the opposite, we are going to add 1 to the power, and instead of multiplying by that power, I'm going to divide by it. So you add 1 to that and then divide by that number. Let's do some examples and just make sure you guys have a good handle on these fun integrals. So let's start off with an easy one. Let's integrate the constant 2. Well, what function gives us 2 out if we take the derivative? Well, 2x plus c. Why? Because the derivative of x is 1 times 2 is 2. The derivative of a constant is nothing. All right, let's try one of these. So what would the integral, actually we'll do this one first. What would the integral of x cubed be? So I'm trying to think of the function, and when I take the derivative, I would get x cubed. Well, I have this rule right here that says, well, I add 1 to the power, and I divide by that number, plus c. Does this work? Well, if I take the derivative of this, the 4 comes down, this becomes a 3, and these 4's cancel. So I get x cubed. So that works perfectly. Now let's try this one. What if I wanted the integral of 2x cubed? What would that be? Well, according to this rule here, it's the same as 2 times the integral of x cubed, which is 2x to the 4th over 4 plus c, which is x to the 4th over 2 plus c. I'm not too worried about changing the c because c could be anything. So if I multiply it plus c times 2, it's still any real number. And that, my friends, is problem set 35.